Hi, welcome to my YouTube channel, Rich Brain. Today's problem is to find a general solution to the differential equation x²d²y over dx² minus 3x dy over dx plus 4y equal to 0. So, if we are met with differential equation, this is a second order ordinary differential equation with a variable coefficient, which is also referred to as Cauchy-Euler differential equation, and a homogeneous for that matter because it's equated to 0. So anytime we are met with a second order differential equation with a variable coefficient for that matter, then we'll let our y to be equal to x exponent m. And the values of the m will determine the general form for our differential equation. And we said that when m is having two distinct roots, then the general equation or the general solution to our differential equation y of x will be equal to c1 s exponent m1, so two distinct roots, plus c2 s exponent m2. That's when the values of m are two different roots. Then it will become, when it is a repeated rule, our general solution will be c1 s exponent m plus c2 s exponent m ln x. Then when m is a complex root system, then our general solution y of x will be equal to s exponent alpha bracket cos beta ln x, then plus I sine beta ln x, where alpha is the real part of the complex root system and beta is the coefficient of the complex parts. So I hope you get that. So when we find the value of m here, it will make us, or it will let us determine which of these is applicable. So come along. So having known that our y is equal to s exponent m, then we will find our dy over ds and d²y over ds². And our dy over ds is a matter of differentiating this. And remember, simple differentiation rule says that we drop the exponent, repeat the function, subtract 1 from the exponent. So the differential of this function will be this. Now we'll find the second derivative. That's d²y over ds². It's a matter of differentiating the first derivative to get a second. So it will be equal to m. We drop the exponent, repeat it, and subtract 1 from this. So m minus 1 will be minus 2. So what next? We substitute y, dy over ds, and d² over ds² into our differential equation. So we have x² in place of d² over ds². We substitute this, which is m minus 1, s exponent m minus 2. That's the whole of this in place of this. So we are substituting that. Then minus 3x dy over ds is m s exponent m minus 1. Then plus 4. Our y is s exponent m. So s exponent m, and all equal to 0. So now let's look at this. The bases are the same. We just add the exponent. So we have s exponent m minus 2 plus 2. Minus 2 plus 2 is 0. So we have s exponent m in that case. So we can say this will be s exponent m times m minus 1. Then minus, look at this. The bases are the same again, s and s. So we add the exponent. So we have s exponent 1 plus m minus 1. 1 minus 1 is 0, so we have s exponent m there. So we say this will be 3 s exponent m times m, then plus 4 s exponent m equal to 0. So you can see that s exponent m is common to all. We factor it out. So we have s exponent m out, m times m minus 1 minus 3m, then plus 4 should be equal to 0. Dividing both sides by s exponent m, we'll just have m minus 1 minus 3m plus 4 is equal to 0. Since 0 divided by any number is still 0. So we can expand this. We'll get m squared minus m minus 3m plus 4 equal to 0. So in simplifying this, we'll get m squared minus negative m minus 3m will be minus 4m, then plus 4 should be equal to 0. Now factors of 4, when we add, we get negative 4. We multiply, we get 4. That will be negative 2, negative 2. So we have m squared minus 2m minus 2m plus 4 should be equal to 0. Now we bracket our first two and the last two. What is common here? M is common, m out. M minus 2 is common, m minus 2 equal to 0. We factor out m minus 2, we'll be left with m minus 2, and all that equal to 0. So our m will be equal to 2 repeated in each of the cases. So we have 2 repeated roots. And remember, when the roots are repeated, then we can say our general equation y of x is equal to c1 s exponent 2, which is m, plus c2 s exponent 2 ln x. So if some boundary conditions are given, we just substitute into the general solutions to get a particular solution. I hope this helps. Please remember to subscribe to my YouTube channel, like, comment, and share my videos, because these are the only ways you can help promote my YouTube channel, and I can record more mathematical content for you. Until we meet again, this is Rich Brain.